Alright, welcome to our lesson on parabolas. It's going to be the fourth and final conic. We've already talked about circles, we've talked about ellipses, and we've talked about hyperbolas. So a parabola is going to be similar to these, but it's going to be different. So a parabola is a set of points whose distance to a fixed point, called the focus, which we've seen foci and focus before, equals its distance to a fixed line, the directrix, which I know this is a strange word, but when we talk about it, I hope it'll make more sense. It's not a tricky concept, we just have to focus in on it. We see parabolas in everyday life, such as arches. Also, this flashlight uses a series of parabolas to focus light beams out. This satellite dish uses a series of parabolas to receive and to send amplified signals. Alright, so the first thing we're going to do is we're going to go ahead and look at a couple of important points. The first and most important point right here is our vertex, as you can see right here. That's going to be the most important point of our parabola. It's going to be the lowest point in this specific parabola. If it was flipped upside down, it'd be the highest point. Okay. Our next point that's very important is going to be our focus. Okay. Now we have been using foci, but that's multiple focuses. So we have a focus, right, just one focus in a parabola. And then this is that mystery line, the directrix, which we will talk about in depth here in just a minute. We also have this distance P, that is the distance from the vertex to the directrix and the distance from the vertex to the focus. Okay, so it's the same distance between the focus and the vertex and the vertex and the directrix. And we'll see more of that in just a minute. First note is vertex is always between the focus and the directrix. Always. That doesn't change. It's always between the focus and the directrix. A vertex always wraps around the focus and goes away from the directrix. So as we can see, it wraps around this way, and then it wraps around the other way, away from the directrix, around this focus in the middle. Alright? Alright, so the next thing that we're going to need to do is we're going to need to go through some terminology with these parabolas. There's two main types of parabolas. We have this one, which is the opening up or down parabola. Okay, so this is the formula that we'll use when we have the opens up and opens down parabola. We have y minus k equals 1 over 4p times x minus h squared. While it seems a little complicated right now, as we go through it, it should become more simple for you. Okay, so our next point is going to be the vertex, which is h comma k, which when we've looked at our center, it's a center in a circle or a hyperbola or an ellipse. We've called it a center, but it's still the same terminology, h comma k for that vertex. Then we have these next three things that are in red. Okay, these three things, while I'd like you to know them, you don't need to really memorize them. We'll find them throughout the work of the problem. We don't need to actually memorize these, but the focus is going to be h comma k plus p. Okay, so that focus point that we saw, that's how we find it with just math. Directrix is going to be y equals k minus p, which if you think about it, if the k value of our y is right here, okay, we got a minus p, that distance p, to get to our directrix. And the same thing with that focus, it's actually a plus p to go up. It's self-explanatory, but knowing the formula is not that important. The axis of symmetry is x equals h. And if you think about it, if you take the h value, which is our x value at our vertex, and you just drew a dotted line straight up here, okay? Well, what you would have is you could fold that parabola just over each other like this, and it would be a perfect match. Okay, that's the axis of symmetry. Now, two big important things for us is if p is greater than 0, then the parabola is going to open up like the one we see here. But if p is less than 0, it's going to open down. So it's just going to be flipped upside down. The directrix is going to be our top thing, then a p, then the vertex, then a p, and then the foci. So it's just the exact opposite. All right, and then we have this other type right here, which is the opens left or right, which is really, we're just going to be switching our x and our y, really, because it's just flipped on its side. So instead of having y minus k, we have x minus h. We still have our 1 over 4p times y minus k squared. Our vertex stays the same. It's going to be h comma k regardless. And then again, in this one is going to be in green, these three things. Again, important to know, but not important to necessarily memorize. So we have the focus, which is going to be h plus p comma k, which again, it's moving on the x-axis, you can see, so that's the difference right there. So to get to that focus, we have to move on the x-axis instead of the y. The directrix is going to be x equals h minus p. Now, again, our vertical lines are always x equals something, our horizontal lines are always y equals something. So again, you can just see visually that the directrix has to be an x equals something. The axis of symmetry on this is going to be y equals k. Where the axis of symmetry was over here was x equals h, because the line was here. This one's going to be y equals k, because it's just going to be right here, but you can still fold it right over top of each other and it'd be the exact same figure. And then, of course, our two important things at the bottom, they've just changed. Instead of up and down, they're now, if p is greater than 0, it opens to the right, like this one right here. Okay? If p is less than 0, then it's going to open to the left. So it's just going to flip everything over that directrix. All right, so an important thing to realize as we look at these is to look at the fact that if it opens up or down, we're going to have y minus k first, okay? And the x minus h is squared. If it opens left or right, it's just going to be the opposite. So x minus h is going to be on the left, and we're going to have y minus k squared. The y is going to be squared if it opens left and right. So just keep that in mind as we look through these next couple problems. All right, so we're going to look at example 1. We're going to find the standard form equation for the parabola with a focus at negative 3, 2 and a directrix at y equals 4. Alright, so the first thing as you is going to be to find our points that we have. So we have a focus at negative 3, 2. So let's go ahead and plot that. So I'm going to go 1, 2, 3 over. I'm going to go 1, 2 up. Now we're going to show our focus by drawing a little x. Okay, that's just the way we show our focus. All right, and then we also know that we have a directrix at y equals 4. So I'm just going to go ahead and draw my directrix at y equals 4. And it's going to be sort of straight, you know. All right. So we have that directrix at y equals 4. We have our focus at negative 3, 2. Now we know something from this, from our notes before, is that the vertex has to be exactly in between our focus and our directrix. Okay, so it looks like the total distance here is 2. And so we're just going to go split that in half, and we're going to go either 1 up from the focus or 1 down from the directrix. And we're going to find this point right here. Okay, so our center is going to be, looks like to me, negative 3, comma 3. All right, so that's going to be our vertex right there. So now we need to look at what standard form equation we need to use. Well, we can look at this and go ahead and make our graph. So because the focus is here and the directrix is here, the graph has got to look like this. It's got to be a downward opening parabola, because it's going to open around that focus. Now again, my x and y intercepts are probably not right, but we're just trying to sketch this just to kind of get an idea of what we're doing. So because we know that it's a downward opening, it's up or down, we can go ahead and pull out this. This is going to be our up or down opening parabola. We have y minus k equals 1 over 4p times x minus h squared. Okay, so the three things that we need to have to be able to do this standard form equation is k, h, and p, which once we have our vertex, we already have the k and the h, and we have the p as well if we have a focus or we have the directrix. okay, which we have all of that right now. So let's go ahead and start writing it out. We have y minus k, which is the y value at our vertex, which is just going to be 3. And we have equals 1 over 4 times a negative 1. Now, why do we use negative 1? Well, from the directrix, did the p go up or down? It had to go down. It went down to the vertex, and then it went down to the focus. It's a downward opening parabola. Because of that, it's going to be negative. So we have negative 1 right there. Then we're going to multiply that by x minus h, which is the x value at our vertex, which is going to be negative 3. So a negative negative 3 is going to be positive x plus 3 squared right there. All right, so we're almost done with this problem right here. We just got to simplify it a little bit. So it's going to be y minus 3 equals a negative 1/4 times x plus 3 squared. All right, so now we have our standard form equation, which that would be our answer right there. Okay, so it's not too bad. Once we find the vertex and either the directrix or the focus, it's not too bad of a process. Okay, so now let's go ahead and let's move on. So we're going to go ahead and do example 2. So in example 2, we're going to find the standard form equation for the parabola with a vertex at 0, 0 and a directrix at y equals negative 4. All right, so again, we have 2 of our very important items, and we should be able to work from there. So let's go ahead and plot our point at 0, 0 for our vertex. And then we're going to have our directrix at y equals negative 4. So I'm going to go ahead and do my directrix again. All right, it's just going to go all the way across right here. All right, so we know that the focus has got to be the same distance from the vertex as the vertex to the directrix. Well, our directrix is 4, 1, 2, 3, 4 away from our vertex. So we can go the same direction. We can go 1, 2, 3, 4, and that's going to be our focus. Now for this problem, they just want the standard form equation. That's not necessary to know the focus in this case, but you know, it's nice to know. All right, so what are the 3 things that we're going to need? We're going to need our h, our k, and our p. We're also going to need to know what formula to use. Well, because it's like this, we have a y equals directrix, and we have our focus and vertex moving up from the directrix, or, you know, and down would be the same thing. We know it's an up or down facing parabola. And in fact, with this one, we can tell it's an up parabola. It's an upward opening parabola because it's got to wrap around the focus and go away from the directrix. So we're just going to draw it right here. That's a nice little representation of it. It's close enough. All right, so now we're going to have to use our y minus k, right here, this formula. So we're going to have y minus k equals 1 over 4p again, times x minus h squared. Okay, so we have our k and our h. Do we have our p? We actually do. If you think about it, we actually do, because we know that p is the distance from the directrix to the vertex. That equals 4. Or we could also look up here from the distance from the vertex to the focus, which is also just going to be p equals 4. So we have everything that we need. All right, so we're going to start doing the problem. It's going to be y minus k, but our k is 0, so we can just leave it as minus 0. I mean, well, let's just put it in here just to be safe. Y equals 0 equals 1 over 4 times p, which is going to be 4, times x minus h, which is 0, 0 squared. Okay, and then we're just going to go ahead and simplify. Now we know that this p is positive, by the way, because again, it moves up from the directrix and up from the vertex. So we can look at that. So we're going to simplify this problem a little bit. It's going to be y equals 1/16 x squared. And now we've just finished. We have our standard form equation right there. So that's going to do it for part 1 of our parabolas. We're going to do some more examples in part 2, including ones that are left and right openings. So make sure you check out those.